So again, today, guys, we're doing laws of exponents. So obviously, if you can tell, my big old head is in the way right here. So I'll let you know what that says, but I want you guys to go ahead and take the notes right here that we see. Because what we're going to do here is I'm going to show you these notes. I'm going to show you some examples, show you some more notes, more examples, and then we're going to get into the practice. Laws of exponents is one of those topics that you have to know the basics. Like you have to know those rules, these little rules. So go ahead, write all of this down here, multiplying and dividing with the same variables. So when you're multiplying powers that have the same base, all you got to make sure you do is add the exponents. And if you don't know what that means, hey, that's okay. Write this down first because I'm going to show you exactly what that means. I'm going to show you exactly what this means. And so obviously you can't see right behind me, this right here, denominator. Right there, that says denominator. All right. So when you're multiplying powers with the same base, again, add the exponents. When you're dividing powers with the same base, you're going to subtract those exponents. So let's go ahead and just really start building some relationships here. When you're multiplying, add the exponents. When you're dividing, subtract the exponents. And when you have a negative exponent, really all that means is, hey, just go ahead and move the power. If it's in the bottom, put it up top, make it positive. If it's on top with a negative, put it on bottom, make it positive. That's really it. It's a very, very sincere, simple rule, but we're going to actually go ahead and understand how it actually works here today. So go ahead, write that all down, my party people, because I'm going to give you just a few more seconds, and then I'm going to show you the next page here with the examples. And always don't shy away from taking a screenshot either. You can always take a screenshot. Screenshots work just fine too. So counting down from 10 seconds here. Again, take a screenshot if you need to. It's all good. All right, perfect. All right, so hopefully I give you guys enough time. So let's go ahead. There we go. We got 4 people coming in. So let's go ahead and move on over here. Up next. So here's some examples. Let me just go ahead and show you how this is going to work. So I'm going to zoom in a little bit. Let's look at some examples. So let's go ahead and just start talking about multiplying powers here, everybody. So remember, everybody, what is the association again? When you're multiplying the same powers, what do you do with the exponents? There you go. Fill up that chat box. There we go. Fill it up. Add. Exactly. We are adding those powers. We're going to add those exponents there. So let me just make sure everybody understands what we mean by base, exponent, and power. Like we got to make sure we know what all that means, right? So let's just make sure here. So over here, this right here, the green, that is your base. Okay. That is the base. So the number on the bottom is called the base. Now, the thing up top right over here, this is your exponent, okay? That's your exponent. Whoops, let me write that a little better. That is your exponent. So when you are multiplying powers, so a power basically just means all of this together. So when you're multiplying powers that have the same base, so in this case, x here, x there, cool. All we have to do is add the exponents. So 3 and 5 together, that makes 8. So the way that you can rewrite it is, hey, x to the third times x to the fifth. That's going to be the same thing as saying, hey, x to the 3 plus 5th power. All right, and 3 plus 5, we all know is 8. So yes or no, on a scale of no to yes, does that make sense before I move forward? Go ahead. Yes or no, does that make sense? All right, perfect. Now let's go ahead and talk about dividing powers here. Let's go and talk about dividing powers. So coming on down with dividing powers. So same idea, guys. If you are dividing powers, again, if they have the same base, so here it's y. If you have the same base, then what you're going to do is subtract those powers. We're going to subtract those powers. And so booyah, 5 and 3, we're going to subtract. 5 minus 3 gives you y squared. Now, let me go ahead and show you why this actually works. Because look, we can learn rules all day long, but if we don't know why they work, then what's going to happen? The moment that there's a pressure situation, you're going to be like, what's going on, right? So I got you. Here's how this works. Everybody, yes or no? Is it true that saying y to the power of 5, is it true that that's the same thing as saying y times itself 5 times? All right, cool. I see that chat box lighting up right there. Yeah, that's what it means. And so watch this. y to the power of 5, that's the same thing as saying 1, 2, 3, 4, 5 y's. All right, cool. Now, true or false again, everybody? Is it true that y to the power of 3 is the same thing as saying y times itself 3 times? Is that true? Right? Absolutely true. Absolutely true. So 1, 2, and 3. So you want to know why you actually subtract those exponents? Well, it's because of this. When you're dividing, everybody, and you got the same thing on the top as the bottom, what do? What is that one thing called that you do when you have the same thing on top and bottom? Mara says cancel. Micah, cancel. Cut them. Cancel them out. Cancel, 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 cancel. Exactly. Cancel them out. That's exactly what you're going to do. And so what you notice is if I'm looking right above me right here, if I'm looking at that, you see that we can take away that y and that y. This y and this y. This y and this y. And so what you get left with is, oh, I'm left with 2 of them. And that means y squared, because that means you have 2 y's multiplied together. That's y squared, 2 of them being multiplied together. Now, does that help anybody understand this even a little better in terms of why that actually works? And so someone asks, why do you need to cancel out the y? That's a great question. So Adam, great question. The idea here is that we are simplifying the expression. So you know how sometimes you can say, hey, how much money do you have in your pocket? You could say $3, or you could say 1 plus 1 plus $1, or you could say 2 plus $1. But what's the easiest way to say it? Just $3, right? And so that's the idea here. We want to shorten how we talk about math because we don't want to take the longest route to say the same exact thing. That's what this is about. We are talking about simplifying expressions here using the law of exponents. And so why is that the same thing over here when it comes to multiplying powers? Well, it's for the same reason, everybody. It's for the same reason. Because when you're looking at x to the power of 3, that's like saying 3x's multiplied together. And on the flip side, if you're looking at x to the power of 5, that's the same thing. You have 5x's multiplied together. So 2, 3, 4, and 5. And so if you look at that over there, you got 3 over here and 5 of them there, and they're all being multiplied. Everybody, let me ask you this. How many x's are being multiplied right there? How many of them total are being multiplied? How many of them do you see being multiplied? That's right, 8 of them. There's 8 of them being multiplied. And so that's why that turns into x to the power of 8. And that's exactly why. And so do you see how like we're using ideas that we already know, but we're just using them to make shortcuts? Oh, when you multiply the same power, add the exponent. Divide the same power, subtract the exponent. We're just shorthanding it. That's all we're doing now. That's all we're doing. And so just to make sure I touch on negative exponents as well. So negative powers right here. It is very, very, very straightforward. So over here, let me just zoom on in just a little bit. I know some people are writing down up top. So again, multiplying powers, add those exponents. Dividing powers, subtract those exponents. But what if we had negative powers? What the heck? Like, what do we do there? Well, look, when we have negative powers, all you have to do is flip it, put it where it's not. So if you have x to the power of -2, everybody, is it fair to say that x to the power of -2 or anything is the same thing as that thing divided by 1? Is it fair for us to say that, yeah, x to the power of -2, we can just say it's divided by 1, right? Yeah, like, 5 is the same thing as 5 divided by 1. 12 is the same thing as 12 divided by 1. X to the power of -2, it's the same thing as being divided by 1. And so all I'm saying is, if you want to make this a positive exponent, just move it to where it's not. Boom. And then turn it positive. That's it right there. That's the rule. That is the rule. And if you look at the other way around, let me just zoom out a little bit. Right over there. If you check that out, if you have the negative already on the bottom, that's okay. Just move it to the top. And there you go, because that's the same thing as y cubed divided by 1, right? And that's it. That's it. So one more time, for those of us that didn't get it, with the negative powers, all you have to write down is this. When it comes to negative powers, move to make it positive So to make it positive, move the power from the numerator to denominator. That's it. And vice versa. And vice versa. And so I'm going to show you in a few examples here exactly why this works, because we're going to need a little bit of an example to actually show how this actually works. But there's the rule. Write that down because we will absolutely be explaining that in a few moments here. All right, we absolutely will. So make sure to have that written down. But again, long story short here, multiplying powers, add those exponents, dividing powers, subtract those exponents. Oh, you got a negative exponent? It's all good. Just go ahead and move it to where it's not. If it's on top, put it on the bottom. If it's on the bottom, put it up top. That's it. And so I'm going to show you again an example of how this last one here works, because this one you need some examples to really show and feel how this works. And so let me just go ahead and start with the power to power here. So go ahead, everybody, take a quick screenshot if you need to. Screenshot this if you'd like to. This we actually don't need to worry about today. We don't need to worry about this today. We're going to be going over multiplying, dividing, and power to power. So this last one here, we don't have to worry about too much. But the one up top right there, power to a power, yeah, write that down. Power to a power, multiply the powers. Yeah, we'll be good today. We got this. Hey, don't worry. That's right, Kaylee. Yeah, so for the previous slide, exactly. If we want to move, if we want to make the, or if we want to get rid of any negative exponents, we make them a positive by simply putting them in the other place, whether it's numerator or denominator. Some people like to say top and bottom of the fraction. Either way is fine. Just move it to where it's not. That's the rule. And so again, we don't have to worry about this today. I just believed it was necessary to write it down because there is a rule for this, but we're not going to be concerning ourselves with that today. We only have an hour, so I want to make sure that we get through things that we can actually, learn fully and confidently. Yes, Ashley, great question. So most times, like literally almost every question that involves laws of exponents, they want you to write the final answer with positive powers. Yeah, typically. All right, so let's go ahead and look at some examples of powers here. So again, we are not going to be looking at this. Let me actually just make sure life is easy for you. So let me just... All righty. Okay, so let me just take care of business here. There we go. So again, I don't want to distract anybody. So we're just going to focus on powers to a power because this is how we're going to have a lot of fun today. I promise you. So power to a power here. Let me just show you a quick example. So let's go ahead and say we got a power like x to the power of 4. We got that whole thing in the parentheses. Oh, God. But then it's to a power of 3. So let me zoom in even more to show you what's going on. Right there should be appropriate. So let me just show you this first example here. Notice how you got x to the power of 4, then cubed. Oh, it's 4 times 3, 12. That is the rule. But let me show you why that actually works. Everybody, the 3 here means we're going to multiply x to the power of 4 by itself how many times? What does that 3 mean? We're going to multiply the x to the power of 4 how many times? How many times? Look at that chat box. I don't think people are lying here. 3, 3, 3, 3, 3, 3, 3, 3, 3. Yes. So watch this. Let me show you exactly why this works. So I'm going to do this. X to the power of 4, 3 times. So what we're going to do is write x to the 4th times itself 3 times. So everybody remind me, what did we say we should do when we are multiplying powers that have the same base? What do we do with the exponents again? What's that rule again? Help me out. Yeah, exactly. We're going to add them. Exactly. We're going to add. And so when you think about it, if you're doing 4 plus 4 plus 4, everybody, is that the same thing as 4 times 3? Is 4 plus 4 plus 4 the same thing as 4 times 3? Yes, absolutely. Absolutely. Yes. And that's why that makes sense. Yeah. So if you're saying anything to the power of 3, so if I say, look, if I went like this, if I said, hey, we got even 2 to the power of 4, that's the same thing as saying 2 times 2 times 2 times 2, right? Like, I'm not lying. That's exactly what it would be. Yeah, 2 times 2 times 2 times 2. And so that's what we're looking at here. We're looking at that and we're saying, hey, to the power of 3, 1, 2, 3. That's all it is. And that's all it is. And we'll go ahead and just add them together, or you can just use a shortcut, multiply them, and you're done. X to the power of 12 is what we would get here. Same thing here. 4 plus 4 plus 4 is 12. So I know that this is a new topic for some people. I know. But from a scale of no to yes, does it make sense when we are using a power to a power, we are just going to multiply the powers? Cool. So the majority here are yeses, but I still see a no, and that's okay. Because once we go through once we go through more examples, I can promise you right now, this is going to be more and more clear as we go along once we start really using our notes with the examples. I got you. So let's look at the second example here. I got you. So we have 2x cubed times y. And notice how, look at this. We have the entirety here in the parentheses, and then squared. This might happen. This might happen. And so this is what you got to do, my party people. This is what you got to do. When you have a parentheses with an exponent outside, if it's just one term like this, if it's just one term, multiply all of the exponents with that exponent outside. What do I mean by that? I got you. Allow me to just make this a little smaller here. Now I can really show you what's going on. So what's going to happen here is, also, wait, hold up. Everybody, there's no exponent on this too. Everybody, and there's no exponent on the y either. Everybody, if there's no exponent on a number or a variable, what can we assume is there? Question. That's a good question. I can't trick y'all today. Can't trick y'all. It's a 1. That's right. It's a 1. Remember this. Another rule. Let me write this down for you. So let me just erase this and make it an orange. And so let me write this down here. Look, if you don't see an exponent on a number or a variable or whatever, the exponent is always 1. So write that down. If you don't see an exponent on a term, number, or variable, it is always 1. Always 1, all right? Always going to be 1. So let me just put that right. Oh. Let me actually put that right there. I'll just leave it right there. It's fine. And so let me just show you what happens here. Let me show you what happens. Oh, everybody, quick, in the chat box, what is 2 times 1? Go. Right, that's going to be 2. Now you see that it's 2 to the power of 2. So notice that was a 1 before. 2 times 1 is 2. Then, everybody, what's 2 times 3? Help me out. Yeah, that x had a 3, but since there's a 2 outside, multiply the 3 and the 2. Boom. And then with the y, everybody, there was nothing on the y. There was no exponent. What exponent's on the y now? There was a 1, and so we'll multiply that 1 by 2 to get the 2. All right, and so don't worry, guys. We're going to get plenty of practice. Trust me, we still have over half an hour left. I got you. We just need to make sure that we have these notes written down because you know how classes go. We need to make sure we have the foundation set so we can get that confidence that we need. But if we're not going to be paying attention to the basics and the notes, then it does get a little harder, and we don't want that. So there it is here, and the only thing that we really have to do is do the 2 squared, which is 2 times 2, and that's 4. Then over here, we have x to the power of 3 times 2. 3 times 2 is 6, and that's why that turns into a 6. And so again, we're just starting off here. What we're going to do up next is we're going to get some practice in. But the way that this is going to work is I'm going to guide you through the first set. Then I'm going to let you guys try the next set on your own, and I'm going to time you. But we got to get started here with the first one. So Sykes, the 4 right here. Oh, I got you. Great question. So everybody, really quick, when you see that you have 2 to the power of 2, That means you're going to multiply 2 by itself. How many times, everybody? Right, 2 times, exactly. So is it fair to say that 2 squared is the same thing as 2 times 2? Right, that's definitely fair to say, right? Definitely fair to say. And so 2 times 2, is that 4? Yeah. And that's where that 4 comes from. So Sykes, does that help you out? Let me know. I got you. That was a good question. I'm gonna look out for Sykes' comment just to make sure that I answered that question well enough for you. Boom. No, again, yeah, if you're confused, you are allowed to ask questions. That's the beauty of this class. That's the beauty of it. So great job there, guys. Great job. So let's go ahead and go through a guided warm-up. So first, we're just gonna start off with multiplying, and then we're gonna go dividing, and then we're gonna get some mixed practice in, all right? I got you. So if you feel confident enough with this and you wanna just go ahead and go gung-ho and try it out, do your thing, do your thing. We're gonna go through these 6 exercises. I'm gonna guide you through it. And then up next, we have dividing, and then we're gonna do some practice. So here we go. Multiplying variables. Let me go ahead and change my font here. Okay, cool. So let's just zoom on in over here really quick to number 1. So here's how we're gonna do this, guys. Notice how we have numbers in front now. Last time, we didn't. That's okay. Because here's what you're gonna do. If we're multiplying all this together, everybody, what should we do with the 7 and the 4? What should we do with that? What should we do? That's right, multiply it, times it together. Exactly. We are literally multiplying. And if you're asking, like, why does that actually work? Well, the reason that that works is because, hey, look, if I'm doing 2 times 3 times 4, guys, that's the same thing as saying 2 times 4 times 3. It's the same thing. If you're multiplying everything together, hey, you can change the order up. You can change the order up. You're fine. You're good. And so you can just take 7 and 4. Everybody, hit me up. 7 times 4 is what? That's right. Exactly. 28. 28. And so that's going to give us 28 with the number here. With the coefficient is the proper term to use. And then let me use blue. We have x squared times x squared. Everybody, what are we going to do with those exponents? We're going to add them. Exactly. That's going to turn into x to the power of 2 plus 2. And I think we know how to do 2 plus 2. I think that might be the best question on the ASVAB if we were to ever get it. 2 times 2, or 2 plus 2, excuse me. That's going to give us 4. Exactly. So our final answer will be 28x to the power of 4. So Frida, I got you. So when you are multiplying, you add the powers. You add the exponents. When you are dividing powers, you subtract. So again, multiplying goes with adding, dividing goes with subtracting. All right. And that's right, Charles. Yeah, 1 plus 1 would have been the same. It would have been the best easy question there in the ASVAB. Or maybe 0 plus 0, who knows? But yeah. So again, the idea here is, everybody, the idea is, again, multiplying powers, add the exponents. If you're confused, write that down a million times. Multiplying powers, add the exponents. Let's take a look at 2. So number 2, we have 2x to the power of 4 times 6x to the power of 3. So the first thing that we're going to take care of, guys, like a good way to make this easy, is to say, hey, look, step 1, coefficients. Again, the coefficients are just the numbers in the front. So not the powers, not the exponents, just the numbers in the front. Take care of those first. So what do I mean by that? So let me just highlight this in blue here. So the 2, let me just make this a little smaller here, a little too big. The 2 and the 6. Everybody, what's 2 times 6? That's right, 12. That's what I mean right there. That's what I mean. Take care of the coefficients first. And then number 2, then take care of the variables. So the wise thing to do is to break it down into smaller steps. Because I think we can all agree that if you try to do the whole problem all at once without really, splitting it up, I think we can agree that it might get confusing sometimes, right? And so that's the idea. We want to just split it up into small, simple steps. And so the 2 times the 6 does give us the 12. X to the power of 4, x to the power of 3. When we multiply those together, we are going to get x to the power of 12. Dang, I can't trick y'all, man. I can't trick y'all. I got to add them. Okay, cool. Yep. We're going to add the exponents. And so you see right there, we are adding them together. And so 4 plus 3, that does give us 7. And so the answer here is 12x to the power of 7. Sin, let me play around. It's my job to help y'all out, but I can have a little fun at your expense a little. I know. All right, so there it is. There it is. Exactly. No, all fun. Like, I mean, all work and no play makes Jack a dull boy. Is that how it goes? All right, so here we go. Number 3. So I'm going to leave this up right here. I'm going to leave that right there. All right. So let me just actually bring it down with us. It's like right on the edge. So it's going to get caught a little bit. There we go. Cool. So I'm going to leave the number 2 up and leave the example there. So let's try this out now. Number 3, step number 1. Let's go ahead and take care of the exponent or the coefficients here first. Take care of the coefficients first. Make your life a little easier. Make your life a little easier. Read down. Doesn't want to behave today. Things happen. But here we go. So we're going to take care of now coefficients 8 and 4. Everyone, 8 times 4. Help me out. Help me out. Help me out. That's right. 32. 32. That's where the 32 comes from. Multiply the coefficients first, then multiply the variables. So the only difference with the variables is that when we multiply the variables, we have to add the exponents. But whoa. What's the problem right here, everybody? What's the problem? Or what might be a problem that some people might face? What is a problem that some people might face here? Right, Kaylee, spot on. And exactly, Margaret. Yeah, some people might look at that and say, yo, there's no exponent. There's no exponent. But what do we say, everybody? If there's no exponent, what's automatically there? What's it going to be? What's it going to be? That's right. 1. Exactly. When you don't see an exponent, it is a 1. It is a 1. And so, boom, that is actually a 1 right there. And so when we multiply, we're going to have x to the power of 3 plus 1, which means we're going to have x to the power of what total? Exactly, 4. 4, 4, 4. And so, booyah, we're good. That's going to be 32x to the power of 4. Who's feeling a little more confident about this as we go along? There we go. There we go. There we go. Again, guys, remember, one problem better, one problem at a time, one day better, one day at a time. That's all you can do. That's all you can do. All right. So here we go. Up next. I don't remember math being this easy in high school. I mean, well, maybe you didn't have me as a teacher in high school. Oh, man. Did I say that out loud? Wow. Oh, sorry, guys. All right. It must be flu season. All right. So number 4 here. So we have 7x to the power of 4 multiplied by 6x cubed. Let's go and try that out. So same idea, guys. Start with the coefficients. Start with those numbers out in front. We got 7 right there. We got 6 right here. All right, cool. What's 7 times 6, everybody? 42. That's correct. 42 is correct. All right, cool. So again, just going to highlight it. I'm going to color coordinate this. That way we can really see what's going on. Next, we have our variables. We got to go multiply our variables now. We got x to the 4th. We got x cubed. One more time, everybody. Pop quiz. What do we do when we multiply powers? Add what? Be specific. Be specific. Be specific. Add what? Add what? Add what? Add the what? Add the exponents. Add the exponents. Add the exponents. You got to be specific there. I want to make sure you guys are saying it correctly. Yep. So we're going to have x to the power of 4 plus 3, which makes it x to the power of. Correct. 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 Great job participating today, guys. Great job. So, yep, that's going to be equal to 42x to the power of 7. So it looks like we're getting, we're in the hang of this, right? We're getting the hang of this. We're getting the hang of this. Let's go ahead and go to number 5 and number 6. And then we're going to go into the dividing variables. And then I'm going to give you time to practice on your own. Let's go. So here we go. Up next, let's just finish off the job here. Let me just move this on down so we always have this in view. I got y'all. Whoops. I left my little dots in my eyes there. Cool. All right. So let's finish the fight here. Let's go. So we have 4 times 2. Quick, everybody. What's 4 times 2? Oh, y'all ready for this? 8. I think I might have missed a question here too. Let me find that question real quick. Okay, no, we're good. We're good. All right, sweet. And then up next, we're going to have k cubed times k squared. What do we do? Add the exponents. So it's going to be k to the power of, that's right, 8k to the power of 5. There it is. There it is, right? One problem at a time. Next, last one here. So we're going to go ahead and take care of 6p cubed multiplied by 7p cubed. Going with it, we got 6 times 7. That's going to give us what? Correct, 42 again. And then we're going to have p cubed multiplied by p cubed. That's going to give us p to the power of 6. And there it is. And there it is. See, look, we're getting so good at this. Margaret is yawning. Margaret is usually punching drywall at this point in the class. She is yawning. So that's how you know this is working. So with that said, we're going to move on up here into the next section here. Margaret, you know. So next up, we're going to get dividing. We're going to start off with dividing now. So as a reminder, you're going to have it right here. Dividing powers with the same base. Subtract the exponents. Subtract the exponents now. So let's go ahead and see what we got. So I'm going to zoom in a little bit so we can just focus on one problem at a time. Actually, I'll keep it like this. I'll keep it like this. That way, if you want to work ahead, hey, feel free to, so you can see more problems. But let's go and try this out. Everybody, is there anything like special about this that'll make it really, 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 really easy? What's the answer going to be? Yeah, it's going to be 1. Because what's the rule, everybody? Help me out. What's 5 divided by 5? 1. Okay. What's 12.6 divided by 12.6? 1. All right, cool. What is pineapples divided by pineapples? 1. Exactly. What's XYZ divided by XYZ? Just 1. Just 1. Anything divided by itself is 1. Anything divided by itself is 1. All right. And so when you look at this, you're saying, yo, this is the exact same thing divided by itself. That's going to be 1. Full stop. No work needed. No work needed. So let's go ahead and move over to number 2. So number 2, we got 6x squared divided by 8x squared. Okay, let's take care of business here. So if we're looking at the 6 and the 8, oh, so Frida asks, what about the p? So again, if you have p squared divided by p squared, you have the same thing divided by itself. That's going to be 1. That's going to be 1. That is the 1 right there. And so you can use the rule too. Everybody, watch this. You can use the rule if you'd like to, actually. Let me just make sure I address Frida's question fully. Let me actually use red here for that. So you see that we are dividing the same base, the same p there. So we're going to subtract the exponents. So we're going to have p to the power of 2 minus 2. Everybody, what's 2 minus 2? 0. Okay, cool. So if we have 1p to the power of 0, everybody, what is anything to the power of 0 going to be? Not 0. Not 0. Ooh, not 0. Anything to the power of 0 is 1. Exactly. Anything to the power of 0 is 1. So one more time. 2 to the power of 0 is 1. All right. Got to know that. Got to know that. Got to know that. And so the reason for that is because when you have something to the power of 0, you are essentially saying that there are just as many being multiplied as there are being divided. And so what that means is it zeroes out, it cancels out in terms of the multiplication and division. And we all know that when we divide the same thing by itself, we get 1. So that's the idea there. A power of 0 pretty much means you have as many of those things up top as on bottom. And so they will cancel out to divide to get 1. That's the idea. So number 2 here, let's go ahead and get to this one. Let's get to this one. Let me let some people in here. So we have 6x squared divided by 8x squared. So here's something that we may not have, something that we may have taken for granted, and it's simplifying fractions. So let me write this out here. This is a skill that you're going to need to develop, especially if you expect to be successful here. Simplifying fractions is a good skill to have. Simplifying fractions is something that we need to have on hand. Okay. So checking out number 2 here. Checking out number 2. Watch this. Everybody, what goes into what goes into both 6 and 8? What goes into both 6 and 8? 2. That is correct. I gave it away for y'all. I know. I just want to see y'all succeed. So with that, what we're going to do here is we're going to divide a 2 from there and divide a 2 from here. Because everybody, if you do the same thing to the top and the bottom of the fraction, is that okay to do? If you do the same thing to the top and bottom? Yeah, exactly. If we do the same thing to the top and bottom, we're good. And so help me out, everybody. What is 6 divided by 2? Correct, 3. And then everybody, what is 8 divided by 2? That's going to give us 4. That's going to give us 4. And then when we take a look at the variables, when we have x squared over x squared, what's going to happen there, my party people? But we're dividing though. What's going to happen? If you're dividing the same thing by itself, Vlad said it best. Yeah, it's going to cancel out and you're going to have a 1. When you're dividing the same thing by itself, it's going to cancel. Notice how 6 is the same thing as 3 times 2. 8 is the same thing as 4 times 2. The 2's cancel out. They get canceled out, so you got 3 and 4. X squared and x squared, oh, they're gonna cancel out. And so all you have left is 3 over 4. All you have left is 3 over 4, and you're good. And we're fine. So with that, what we're going to do now is let me try to find one more example problem that we can get behind here. I would love to show you one where we are actually subtracting. So let me go ahead and show you number 3 real quick. And then we're going to go forward into the mixed practice where I'm going to time you because I know it's 6:48 right now. I want to get at least one full set of practice. That way you can really bring this all together and feel good about moving forward. So number 3, we got 6k to the power of 4. And I see that we need to make sure that we can see up top there. I got y'all. There we go. So number 3 is what we're focusing on right here. So we have 6k to the power of 4 divided by 3k to the power of 3. So first things first, like I said, start with the coefficients. What is 6 divided by 3, everybody? What's that going to be? Yeah, it's going to be 2. It's going to be 2. So we're going to have a 2 up top there because what you're going to do is divide the 3 out here and here, which cancels out right there, leaving you with just 2. And so up next, now we have k to the power of 4 divided by k to the power of 3. How many of those k's are going to cancel, everybody? How many of those k's are going to cancel? 3 of them exactly, because you have 4 up top, 3 on bottom. When you lay it all out, you got 3 up top and 3 on bottom that are going to cancel. And then there's going to be 1 left up top. Or just use the rule. Okay, dividing powers, subtract the exponents. 4 minus 3 is 1. So you have 1 of those k's left up top. And so you can say this is 2k divided by 1. This is the same thing as just saying 2k. Same thing as just saying 2k. Let me just fix that up real quick. Same thing as saying 2k. Same thing there. I mean, I wish 2K got the chance to make NFL games, honestly. Yeah, that's all I got to say about that. So with that, yeah, you can still put the 1 for yourself. Yeah, exactly. These are both correct. These are both correct. These are both correct. Those are absolutely both correct. Yeah, dividing is a little different. And that's why I want to give you guys the chance to practice here. So here's what's going to happen up next. So let me zoom in over here to show you what's going on. So notice you got a practice set coming up right below this, okay? You got a practice set coming in. And I'm looking at it, and it's definitely doable. Like I'm checking it out right now, obviously, and it looks good. But hey, look, I'm gonna give you 3 minutes. I'm gonna give you 3 minutes to try it out. And what did I say, everybody? Is it the end of the world if we get a problem wrong? Yes or no? Is it the end of the world if we get a problem wrong? Margaret. It is not, Margaret. Again, you probably have replaced so much wall in your house, probably punching through everything. No. So, what is more important, everybody? It's not about getting the problem right or wrong. It's about the what. Say it with me. It is about the why. It's about the why. Again, there is nothing wrong with being wrong, but there is something wrong with not trying to understand why. If you're going to get the problem wrong and just get pissed off and walk away without doing anything about it, yeah, you're wrong for that. Yeah, that's a bad situation. But if you make a mistake and you just simply ask, hey, what was the mistake so I don't make it again? That right there is what you want to be. Because it takes your ego out of your head of saying, oh man, I got it wrong, I'm going to run away. Like, come on, man. Like, we're human. We're going to get problems wrong. Be okay with it. And let's move forward the right way. So I'm going to give you guys 3 minutes here to do as many of these as you can. We're going to go over it and we're going to see what we got after that. All right. So with that said, my party people, 3, 2, 1, let's go. When you're done, type ready when you're ready. Yeah, so if you notice, the practice is mixing in both. Yeah, the practice is mixing in both, absolutely. And so I'm going to do my best to zoom in here as much as I can, because I know that we have these problems that I don't want to cut off, obviously. You see my big old head getting in the way? So what I'm going to do is I'm going to go ahead and periodically zoom into different problems, okay? Periodically, I will zoom in to different problems. So we'll start here. I got you. And periodically, I'll zoom in a little bit. So here's number 1. Take a screenshot if you need to. It's all good. Here's number 2. Take a screenshot if you need to real quick. It's all good. I know for those of us on our phones, it's not the best. That's all good. All right, number 3 is coming up right now. Just take a quick screenshot if you need to. Take a quick, it's all good. Take a quick screenshot. All right, and I'm going to show you number 4 here. Then I'm going to zoom back out and I'll write them a little bigger if you need me to. I got you. There's number 4. Take a screenshot if you need it. I got you. All right, there you go. There you have it. Those are all 4 there. And so I'm going to drop some hints too. I got you. I'll drop some hints. Hey, it's all good. Do your best. At least write the problems down first, because we're going to go over all of them right now. I got you. So we have about 30 seconds left here. So don't worry, I got you. I'm going to show you how we can go from no confidence at all to, oh, I can see what we can do first. And then from there, what we can do next and next and next and next. I got you. Let me just erase that actually. So we have just about 5 seconds here. It's all good. 4, 3, 2, and 1. So how many were you able to finish? Regardless of whether you believe you got them wrong, how many do you believe you were able to finish? Okay, I got some 1s, some 2s, some 3s, 1s, all 1s and 2s and 4, all. Okay, so I see that the majority of us, about 2, was we were able to get, which is fair. That's actually very fair. So let me go ahead and let's lead the way here, and let's go and show ourselves how we go ahead and do this. So here we go. Let's just start off calm and easy. Number 1, watch this. So everybody, what do we notice? Do we notice that we are multiplying powers, dividing powers, or both? What do we notice? Right, we're doing both. We're doing both. We are absolutely doing both. So watch this. So if we're doing both, treat this like a fraction problem. You know how with fractions, when you're multiplying fractions, you can multiply, then simplify? Or if you wanted to, you could simplify, then multiply. It's really up to you. It's really up to you. I'm going to do this the straightforward way, and then I'll show you a little shortcut that I like to use. So let's do it the straightforward way. Let's multiply first. So here's what I'm going to focus on. I'm going to focus on first right here. Okay, that's what I'm going to focus on. So what that means is that 2v squared on the bottom, it stays the same. Stays the same. Nothing got done to it. Nothing got done to it. Let's just focus on this right here. So everybody help me out. Is this a little easier? Do we know what 2 times 5 is? Help me out, everybody. What do we do? What's 2 times 5? Help me out. Okay, cool. That's 10. Okay, great. Now, what is it that we do again when we are multiplying powers? V cubed and V. What do we do there again? Add what? Guys, stop being lazy. Add what? Add what? Stop being lazy. Add what? Add the exponents. Add the exponents. Add the exponents. That's right. Come on, let's not be lazy today. We're good. Add the exponents. That's exactly what we're going to do. And so we're going to have V to the power of what, everybody? V to the power of what? Adam, we'll get that out of you, man. It's all good. So boom, V to the power of 4. That's what we have exactly. We have V to the power of 4. So when we're here now we can go ahead and really mess around with everything else. Now we're doing the division. So you see what we just did there? We simplified the problem by breaking it up into 2 steps. The first step was, let's just go ahead and multiply what's up top. And step number 2, now let's go ahead and divide. Everybody, do you see what I'm doing there? Do you see does that give you a little more confidence in terms of what to do? Multiply what you see first and then go ahead and divide. You got to give yourself that chance, right? You got to give yourself that chance. You got to break it down into small, simple steps. So here we go. Everybody help me out, man. What is 10 divided by 2? Okay, that gives me 5. And then help me out one more time, my party people, one more time. What do we do if we have V to the power of 4 and V to the power of 2? What do we do with the exponents when we are dividing powers with the same base? What do we do again? Subtract, subtract, subtract. Yeah, subtract. We're going to be subtracting those exponents. So we're going to have V to the power of 4 minus 2. That's what you do again. You subtract the exponents. And so officially, that's going to give you 5V squared. And that is answer B. Who got number 1 right? It's a car. There you go. You're I love it. I love it. I love it. Hey, it's all good. Even if we didn't get it right, it's all good. Because the next question is, do you understand why? Do you understand why? Do you understand what your error may have been? Hey, Steve, it's all good because now that you see what I did, I bet you can start applying that to the next problem here. So let's try out here with number 2. Watch this. With number 2, what do we got? Okay, so I'm looking at number 2 right now, and I'm like, hey, oh yeah, there's more than one way to do it. I just want to make sure that I show you the other ways here too. So allow me just an extra couple of minutes here because I really do care about your success. I got y'all. So number 2 here, we got 3r squared up top. Okay, that looks pretty ugly to me. Not really. It's just there, whatever. But on the bottom, this is where the party's at. We got 2r cubed multiplied by 5r. So that denominator right there, that red denominator, that's what you're looking at. You're like, yo, let's take care of that first. Let's take care of business first there. So let's go ahead and get after it. The 3r squared, that's just going to stay as 3r squared up top. So we're good. We're good. But now look at the denominator. Look at the denominator. We have the 2r cubed and the 5r. Everybody help me out. If we're multiplying this, everybody help me out. 2 times 5, what's that going to be? Yep, that's going to be 10. All right, cool. And then if we have r cubed multiplied by r, wait, hold up. What exponent is going to be on the r? I don't see an exponent right there. What exponent is going to be on r? Yes, that's going to be a 1. So if we have r cubed times R1. What do we do with those exponents again? Add. We add them, exactly. Not dad, add. So we're going to have R to the power of 4. Because again, boom. And that's what we have now. So notice this is actually a little more manageable now, right? A little more manageable. Anybody, hey, can we simplify the 3 and the 10? Is that simplifiable? Is that simplifiable? Quote unquote. Nah, that's not simplifiable. Nah, we just leave it as is. We leave it as is, and that's going to be 3 over 10 there. It's not simplifiable. Can't do it. But now let's go ahead and take care of R squared and R to the power of 4. Everybody, how many R's are going to cancel out? Because we have 2 of them up here, 4 of them down there. How many of them are going to cancel out? 2 of them are going to cancel out. Exactly. But let me show you how they're going to cancel out. There's 2 ways of thinking about this. I got y'all. There's 2 main ways to think about this. One is you can say, hey, let me go and just scroll up a little bit here. One of the ways is saying, hey, this is like saying R times R. And this is like saying R times R times R times R. Is that a fact or is that false? Everybody, R squared is like saying 2 R's multiplied together. R to the power of 4 is like saying 4 of those R's multiplied together. Is that a fact or is that false? Mario, hey, that's facts, B. Yeah, the facts, right? That's a fact. That is a fact. Now let's take care of business here. Is it true that this R and this R are going to cancel out? All right, cool. Is it also true that this R and this R are going to cancel out? Yeah. So like we predicted, we're going to have 2 R's left. But where do those R's belong? Right. They belong with the 10. They belong on the bottom. They belong on the bottom. These 2 R's right there belong on the bottom. And so the answer here would be 3 over 10R squared. Right over here, that's going to be A. But let me show you the other way. I got you. Stop right here. Pause, pause, pause. Let me show you the other way so you can really see how this works and how math is not just, oh, there's only one way to do it. Look, if you were ever taught that your teacher was like, just do it my way, you're only going to do it my way, you're only going to ever do it my way, I am sorry. Those kind of teachers they want to make me do backflips. Like, just out the door. I never want to come back. Let me show you the other way. So I'm going to copy this real quick. Let me just copy this over. I got you. And I put this right over here. Okay. So allow me to just do it the other way. Let me just get my big old head out the way real quick. There we go. All right. So let me help y'all out. Let me help y'all out again. So, all right. So we're at the point where we already discovered that, yeah, you know, the 3 and the 10, you can't do anything about it. There it is. There it is. But what do we do again? What was the rule that we wrote down? When we have variables, same base, and we're dividing them, what do we do again? Full statement there. Full statement. Subtract what? Subtract what, Felicia? Subtract what? Subtract what? Subtract the exponents. Yeah, that's right. Subtract the exponents. We're going to subtract the exponents. So everybody help me out here. What is 2 minus 4? Positive 2 or negative 2? Which one is it? If I'm doing 2 minus 4, yeah, because I'm taking away more than I have, right? If it was 4 minus 2, yeah, that'd be positive 2. But if I'm doing 2 minus 4, that's a negative 2 because I'm taking away 2 more than what I have, right? So that's going to be negative 2. All right, so you know where that goes? Watch this. Right here, but then we're going to write to the power of negative 2. And so everybody, what did I say? What was that rule again? If you had negative powers, if you have a negative power, what do you do with that part of the term? What's the only thing you got to do? Right, switch it over, flip it over, exactly. And so let me be very specific here. Let me be very specific here. It is this, only this. Because notice, the negative 2 is not on the 3. The negative 2 is not on the 10. The negative 2 is only on the R. So it's only the R negative 2 that's going to flip down to the bottom. Does that make sense, everybody? It is only the piece that is a negative exponent that gets flipped, not the whole thing. just the negative piece. And that's why this moves down here to create the correct answer of 3 over 10r to the power of 2. That is why A is correct again. So on a scale of 0 to your, how much sense did that make to you? Nice. And again, I don't expect it to be, all pretty for everybody. And please try not to spam the comment box. I want to make sure I'm getting a good read on everybody here. Because I do see a lot of 10s, but I see some 5s there. And so would a 5 mean that, is it fair to say that a 5 is like saying, with my notes, I could probably do this. Like if I had all the notes in front of me while I practice, I could probably do this, but I'm just not quite confident enough to be ready for the test yet. Is that what a 5 sounds like? Yeah. In the ballpark, we need work. Cool. And that's fair. That's fine, right? Because it takes time to grow into it, right? You can learn your multiplication tables, but you have to actually practice and practice and practice to actually feel it through. And so I want to go ahead and give you all guys the opportunity to go ahead and screenshot these. I'm going to give you the answers to 3 and 4, and then we are wrapping this up. But again, if you are here and you don't have the class pass, stick around because I got you. So here, number 3, the answer is going to be, it's going to be A. Over here, it's going to be A. So go ahead and take a screenshot of that. That way you know the answer is A for number 3. And then 3, 2, 1, moving on to number 4 over here. So number 4, we're looking at number 4 here. The answer will be 9K cubed. So that's going to be C. That is C. So number 4 is C. 4 to 4. Hey, there we go. There we go. There we go. There we go. So my party people, there it is. There it is. Look, I really got to make sure I thank y'all for coming to class today, honestly. If you are not, again, read this right here. If you are not in the All-Access Pass, you need to stay for a second. Because again, if you are in the All-Access Pass, I'm about to let everybody go here. But really quick, I need to understand this. What was the most important information that you learned today? Go ahead. What was the most important information that you learned today? Type it into that chat box. Let's reflect here really quick because apparently we learned a lot. Multiplication rules, division rules, power to a power, negative.